What's happening, everybody? Pastic here with another video. In this one we're going to be talking about relations and functions and how are they connected. We are going to identify properties of functions and evaluate function rules. So let's do that. So this one, it says to determine whether each relation is a function. In order to do that, you need to know what a relation is and then what a function is. So I'm going to talk about them first, and then we'll try to come up with a definition. So I'm looking at the first one. First function consists of 4 points, 4, 3, 2, -1, -3, -3, and 2, 4. And remember that these are all x's and y's, right? And you're going to hear me talk about them as inputs and outputs. So x is your input, and y is your output. A function is basically an equation that receives an input and produces a specific and unique output. So 4 gives you 3, 2 gives you -1, -3 gives you -3, and 2 gives you 4. I don't care what the equation is. All I care is that each one of these x's gives me exactly and only one of these y's. So the 4 gives me a 3, the 2 gives me a -1, the -3 gives me a -3, and the 2 gives me a 4. So based on what I just said, this is a function because every input has exactly one output. So I'm going to write that. So I've written that this is a function because each input x has exactly one output y. Another way to quickly check, and this is just a quick eyeball check, and it works 99 times out of 100, you look at the first value each time. 4, 2, -3, and 2. And I realize I just screwed up. This is actually great because I didn't look close enough. If I look at this point right here, 2, -1, and this point right here, 2, 4, you'll notice both of those inputs are the same, 2 and 2. When you have something like that, the only way for it to be a function is if the outputs are then the same, but they're not. So for the first one, 2 gives you -1, and then the second one, 2 gives you 4. Well, that doesn't make any sense. If I got an equation and I plug in 2, I better get the same answer every time. In this part, I'm getting -1 and I'm getting 4. And that is no good. I've got the same input, 2, giving me two different outputs, -1 and 4. That doesn't make any sense to me, and that means it's not a function. So I'm going to write that, and I'll be right back. So I've rewritten my answer, which is excellent. I'm glad you saw that mistake. So it says this is not a function because the input of x equals 2 has more than one output. Our input of x equals 2 has an output of -1 here and +4 here, and that is not possible when you have a function. And I kind of drew a little diagram where my input of 2 is going to two separate outputs, -1 and 4. That is no good. If you can draw something like that, then that means the relation that you are given is not a function. So same idea with this one. Let's take a look. First thing I always do is check, do the inputs repeat? -4, -2, or +2, -1, and 1. None of the x values repeat. If none of the x values repeat, then you don't have to worry about having more than one output because there's only one output for each x. So -4, 2, -1, and 1. None of those repeat, therefore you can't have this situation over here where you have a single input going to multiple outputs. So this is a function because every input has exactly one output. I shall write that. The nice thing about this is that when I write my answer to tell if it is a function or not, I'm defining a function every single time. So when I write this is a function because each input has exactly one output. That is the definition of a function. A function is a relation where each input has exactly one unique output. And a relation is just any set of points. So when you think of a relation, you think of an equation, a graph, a table, a set of points like this. These are all relations. So basically a relation is any set of points that go together. There doesn't even have to be a pattern or an equation. It just has to be a set of points, period. So on to the next one. This one says we want to use the vertical line test, which I would say get familiar with that. So if you don't know what that is by the end of this slide, you're going to want to watch a video on the vertical line test or ask me about it to determine whether the relation is a function. So in order to do that, I need to graph these points. I'm going to graph the first one, and then hopefully you can graph the rest. So the first one, 3, 2, means I'm going to go right 3 units from the origin, and I'm going to go up 2 units from there. So I'm going to start in the middle, go right 1, 2, 3, and then up 2, and I'm going to put a little X. On yours, you should be drawing dots. I put X's because it's easier to do on my board. I'm going to graph the rest, and I'll be right back. So I graphed the rest of my points, and you can see I tried to color code them for you. And I also drew little arrows, kind of giving myself an idea of which direction to go. When I plot a point, I always start in the very middle of the graph in the origin, which has coordinates of 0, 0. And then I move left and right according to the X value, and I move up and down according to the Y value. So I'm trying to give you as much of a hint there as I can. It says to use the vertical line test to determine whether the relation is a function. So to do that, I'm going to draw a vertical line through each point and see if it hits any other points on the graph. Each one of the vertical lines that I have just drawn hit exactly one of the points in the relation. Because they don't hit more than one, they are indeed a function. If any of my vertical lines hit more than one point, then this would not be a function. So I'm going to sum that up with a quick sentence. So I've written my answer here, and it reads as, this relation is a function because every vertical line that can be drawn contains no more than one point. I drew my 4 vertical lines through each one of the points. Each one of those vertical lines contains exactly one point, no more than one point. Therefore, it is a function. And this is how you want to respond to this question. If I were to come onto this graph and draw another point here, right there where x equals -2, that would make it no longer a function because now you've got 2 points existing on the same vertical line. That would fail the vertical line test and therefore make it not a function. So again, this one does pass the vertical line test. It is a function because every vertical line that you can draw contains no more than one of the points in the relation. Beautiful. So this one wants us to make a table for f of x. The way you read this, I should probably talk about that, is f of x So I read that as f of x, or function of x, that's another way I've heard it read, equals 0.5 times x plus 1. We want to use 1, 2, 3, and 4 as domain values. Domain values are just values that are possible for the inputs. Whoa. So when we talk about domain from here on out, we're going to be talking about possible input values. And if you hear the word range, range will be different from your previous understanding of the word range. Range used to mean high minus low. Now range for functions means all the possible outputs, or the y's. So domain is inputs, is x values, and y is outputs, is range. And it's kind of easy to remember. Domain starts with a D, comes before range, starts with an R. X comes before y, so it's domain, comma, range. That's something I would definitely write down. So I'm going to fill out my chart, and then I'm going to show you what I'm doing from there. So I've begun to populate my chart. Going down the first column on the left, I've got the x values, 1, 2, 3, 4. In the middle, I'm going to show what the function equals. F of x equals 0.5x plus 1. And all the way on the right, I'm going to write the y values. And the reality is this. The function of x, f of x, is equal to the y value. So when you plug in your x, you get your y. It's input, output. So we'll do the first one together. I'm going to write f of 1 equals 0.5 times 1 plus 1, which equals 0.5 plus 1, because I did this part, which equals 1.5, and that is my output for my y value. So now I shall pause this and do the rest, and you should do the same. So as you can see, I've filled in all of my table values. I have 1 comma 1.5, I have 2 comma 2, 3 comma 2.5, and 4 comma 3. The other thing I would encourage you to do is when you're doing this process here, look for patterns. I notice that these outputs, these y values, these range values, are going up by 0.5 each time. So I can quickly check to make sure these are going up by 0.5, and that's a good thing. And once I notice that the points are going up by 0.5, I actually want to make a connection. Look at right here. 0.5 is the coefficient. The number next to the letter is 0.5, which is the coefficient of x. It also happens to be the rate of increase here, 0.5, 0.5, 0.5. So that's something to get your brain cells going. So kind of a similar problem here, and I talked about some of these words in the previous slide. It says evaluate the function rule f of g equals negative 2g plus 4 to find the range for the domain of negative 1, 3, and 5. So I read this, I know that g is my input, and that means g has the domain values. And I come over here, these are my domain values, so these are going to be values for g. Which means we have to perform this function rule 3 separate times with 3 separate inputs. And they want us to find the range. The range is going to be the set of output values. So we're going to do the first one together, and then I hope you will do the last two by yourself. So f of g, I'm going to plug in negative 1. F of negative 1 equals negative 2 times g, so times negative 1, plus 4, and then we're going to do that out. So negative 2 times negative 1 is 2, plus 4 equals 6. So for our answer over here, we're going to write the word range, and I'm going to do a little squiggly bracket. My first range value is 6, and now I'm going to find the rest. So I've completed the last two evaluations of the function, and keep in mind, this is the word we're doing here. We're evaluating the function rule. We've been evaluating for a long time. Evaluating just means plug in a number, see what you get. Do not solve. I see so many times people are trying to like add, subtract, divide, solve things when it comes to this. It's not what it's asking you to do. It's saying evaluate, which means plug in the number, chug through the order of operations, and see what your output is. So for the input of negative 1, we got 6. For the input of 3, we got 2. For the input of 5, we got negative 6. These 3 outputs make up the range for the given domain. So our domain was negative 1, 3, 5. Those were my inputs. Our range is 6 to negative 6. Those are my outputs. And I think that's all I got for right now. That is it. So I'll catch y'all next time. Hope you learned something. Take it easy, y'all. Just kidding, I can't stop it.